Welcome to The Explainer. Today, we are going to trace the absolutely incredible journey of a single mouse click. In those tiny milliseconds after you click something, there's this hidden world, a universe really, that just explodes into action, turning your simple command into, well, just about anything on your screen.
I mean, think about it. You click an icon and boom, a program opens. You type and letters just pop, appear. It feels like magic, right? Instantaneous. But it's not. It's this perfectly choreographed dance of data, happening billions of times a day inside your machine.
All right, so let's break this down. The whole thing, everything a computer does follows this super fundamental three-step process. It's called the IPO cycle: input, process, and output. That's it. From launching a game to sending an email, it's always those three steps, in that order. Okay, let's start at the very beginning. Our journey kicks off with that first, critical spark, the input. This is the moment you tell the machine, hey, do this.
So that physical click, the actual press of the button, that's the starting pistol for this whole race. It sends a tiny little electrical signal shooting into the heart of the machine, carrying your command. It's the very first step, just raw data entering the system.
So where does that little signal go? Well, it travels from your mouse straight to the computer's central command center, the processor. This is where the magic really starts to happen, where your simple click gets turned into a complex action. And this command center has a name you've probably heard, the Central Processing Unit, or CPU. You can just think of it as the brain of the whole operation. And when I say brain, I mean it. We're talking about a tiny chip that can handle billions of instructions every single second. To give you an idea of how fast that is, it's like reading every single book in a massive library in the blink of an eye. Yeah, it does all the heavy lifting. And inside this brain, there's a little core team working together. You've got the ALU, the Arithmetic Logic Unit. That's the mathematician. It handles all the calculations and logic. Then there's the CU, the Control Unit. Think of it as the traffic cop, directing all the instructions to the right places, making sure there are no crashes. And finally, you have registers, which are like a super fast little scratch pad for holding tiny bits of data the CPU needs right this second. All of them working in perfect sync. But even the smartest brain needs a place to work, right? A workbench to lay out its tools and current projects. For the CPU, that workbench is called RAM, or Random Access Memory. It's this high-speed, but temporary, spot for all the data and programs the CPU is actively juggling at this very moment. And this is a really crucial point. There's a big difference between RAM and its cousin, ROM. See, RAM is volatile. What does that mean? It means if you turn the power off, it forgets everything. Poof, gone. Just like wiping your workbench clean. ROM, on the other hand, is non-volatile. It holds the permanent, fundamental instructions the computer needs just to wake up in the morning, the boot-up sequence. Okay, so the CPU has done its work on the RAM workbench. Let's say you've finished typing a document. Now what? You can't just leave it on the temporary workbench, right? You got to put it away somewhere safe, somewhere permanent. You need to file it in the digital filing cabinet. But here's a thought. What happens if the information we're trying to save is, well, flawed? This brings up a core, super important principle in computing. Garbage in, garbage out, or GIGO for short. A computer will do exactly what you tell it to. It'll dutifully store whatever you give it. But if that initial input is garbage, guess what the stored result is going to be? Yep, garbage. The accuracy of your digital filing cabinet depends completely on the quality of what you put into it. So, let's talk about the size of this filing cabinet. How do we measure all this digital stuff? Well, it all starts with the tiniest piece, a bit. That's just a single 0 or a 1. Put 8 of those together, you get a byte, which is enough for one character, like the letter A. A kilobyte, that's about a page of text. A megabyte could be your favorite song. Your phone probably holds gigabytes of photos and apps. And a modern hard drive, we're talking terabytes. That's enough space for thousands of hours of movies. Okay, but why should you care about this stuff? Here's why. The type of storage you have dramatically affects your computer's speed. It's a night and day difference. The old school hard disk drive, the HDD, has these spinning platters, kind of like a tiny record player. It has moving parts. But the modern solid-state drive, the SSD, no moving parts at all. This is literally the difference between waiting a whole minute for your computer to start up versus just a few seconds. It's a huge deal. All right, we've had the input, we've had the process. Let's get to the payoff. The final step of the cycle.
Let's see how all that crazy fast processing and storage actually becomes something we can see and use. This is the output, and it's all brought to life by software.
So, who's the conductor of this entire digital orchestra? That would be the operating system, or OS. You know it as Windows, Mac OS, Android. It's the master software, the bridge that connects you to all that complicated hardware. It manages everything behind the scenes, so you don't even have to think about it.
And man, the way we talk to the OS has changed so much. It's kind of wild. We went from the old school character user interface, the CUI, where you had to be a bit of a wizard typing these cryptic commands into a black screen, to the modern graphical user interface, the GUI. That's what we all use today. We just point and click on colorful pictures and icons. Honestly, this is what made computers something everyone could use, not just the experts.
So if you think about it, all the software on your computer can be broken down into 3 main teams. First, you have the system software. That's the foundation, like the OS and all the basic drivers that just make the machine run. Then you have the application software. These are the programs you actually use to get stuff done, like Chrome or Microsoft Word. And finally, you've got utility software. Think of this as the maintenance crew, the antivirus and cleanup tools that keep your computer healthy and running smoothly.
Look, a single computer on its own is powerful, no doubt, but its true potential, that's only unlocked when it starts talking to other computers. And that brings us to the world of networking. So the first step to getting your computer out into the world is a little box called a modem. And its name literally tells you what it does. It comes from modulator demodulator. It's basically a translator. It takes the digital language of your computer and translates it into analog signals that can travel over old phone lines or cable lines, and then it does the reverse for incoming signals. It's absolutely essential. Okay, so the signal's inside your house now. What happens next? A switch comes into play. You can think of it like a smart mail sorter, but for your local devices. It knows that a document you're sending from your laptop is meant for the printer and not for your smart TV. It intelligently routes all the traffic inside your home network so things go to the right place. And finally, there's the router. This is the dispatcher. Its big job is to connect different networks together. So it takes all that traffic from inside your home, which the switch is managing, and directs it out to the big wide world of the internet. And of course, it manages all the traffic coming back in. It's your home's gateway to everything else. So you put those 3 things together, the modem, the switch, and the router, and what do you get? You get a connection to the biggest network of them all, the largest wide area network that has ever existed, the internet.
You know, it's just staggering when you step back and look at how far we've come. The first generation of computers, they used these things called vacuum tubes and filled up entire rooms, and they were less powerful than your pocket calculator. Then we got to the 3rd generation with integrated circuits, which gave us keyboards and monitors. The 4th generation gave us the microprocessor on a single chip, which led to the PC on your desk right now. And today, we're living in the 5th generation, an era that's being completely defined by artificial intelligence.
And that whole incredible journey brings us to a final, really provocative thought. For decades, we've built machines that are absolute masters of processing information. They can do it at speeds we can barely comprehend. But as we dive headfirst into this new era of AI, the ultimate question isn't about speed anymore, is it? It's about understanding. We've mastered the what and the how of computing. The next great frontier, the real challenge, is the why.